Hello, folks. Mr. Dell here. We are looking at a system of equations problem where we'll solve it graphically and using the equal values method. So this is a problem from CPM's course 3, and this is section am I in? 9.1.4. And number specifically 9-48. So it says solve the system of equations to the right by each of the ways described in parts A and B, then compare your answers in part C. So part A says graph the system on graph paper, then write its solution. And remember, the solution to a system is that point of intersection. It's where there's a common X and Y for both equations. So how do we graph? A reminder of how to graph. Remember, the form of this equation is y equals mx plus b, where b is your y-intercept, okay, and m, so b represents the y-intercept and m represents the slope or that rate, right? So when we look at this equation here, let's start with the first one. Y equals negative 1x, there's a 1 there, negative 1x plus 1. So my y-intercept is 1. So remember on your graph, that's your y-axis, that's your x-axis. So where y is 1 and your positives are up, negatives are below, right? It's two number lines. So this is the positive y's this direction, negative y's this direction. Positive x's this way, negative x's are this way. So if we're going to go 1 on the y, it's right there. Then my slope is negative 1. That means, and slope, remember, slope is described as the change in y over the change in x. So change, that's delta y, delta x, change in y. So if I have 1, negative 1, what that means for this one is your slope is negative 1 over 1, right? Negative 1 is negative 1 over 1. So in other words, it's going to go down 1 over 1, right? It's a negative slope, so it's going downhill, and it's a 1 over 1 change. The change in y over the change in x, change in y over change in x. So for this slope, it's negative, so downhill. It's decreasing, and it's 1 over 1. Every 1, you go over 1, right? So once I have enough points there, I can graph that by drawing my line. I had to grab my ruler. Sorry there. Okay, so we've got my line for this one. And it's 1 over 1. So all the way through, my slope should be consistent, right? And so there's my line for y equals negative x plus 1. Now I'll draw the next one, y equals 2x plus 7. So with this one, again, your y-intercept is 7. So at 1, 2, 3, 4, 5, 6, 7. Okay, so it's at 7 is where this one crossed at 1. That one crosses at 7. And this time, this slope here is 2, which is 2 over 1. So my change in y is 2 over 1. So I'm going up 2 over 1. And I'm going in a increasing. So if I'm increasing, then I want some points going the other direction, down 2 over 1, right? I have this same pattern on my slope. The change in y is 2, the change in x is 1. Change in y is 2, change in x is 1. And as long as my pattern here has an uphill increasing pattern, then that's my slope, and that's my line. So if I connect those dots, we end up with this as my line. So this line is y is equal to 2x plus 7. So keep in mind, the solution to this system, those two equations, is the point of intersection. Because right there where they intersect, that's the place that the x and y are the same for both equations. Because when you graph, you're graphing to show all the solutions. So all the possible pairs of numbers that work for y equals 2x plus 7, and all the possible pairs of numbers that work for y equals negative x plus 1. So the pair of numbers that works for both is right there. And where that is the y is, or excuse me, the x is at negative 2 and the y is at positive 3. So that's at negative 2, 3. So negative 2 comma 3, according to my graph, would be the solution to this system because that's where they intersect. So that's solving it graphically. Now, we also can solve it using the equal values method. And what does that mean? Well, that means taking these equations and you're now going to do some algebra to the sense of I'm looking for the x that makes those y's equal. So I want to know where are those y's the same, so I set what the y's equal to each other, right? This is equal to this y, this is equal to this y, but those y's, I want to know when are they the same, so I set them equal. So negative x plus 1 is equal to 2x plus 7. So I create an equation where I'm now looking for the x that makes both of these true, equal. So if I'm going to solve for x for this case, I'm going to go ahead and add x to both sides over here because I want x's all on one side. At the same time, I'm going to get my numbers on this side. So I subtract 7 from that side. So we end up with negative 6 is equal to x. 2x plus 1x is 3x. So x is equal to negative 2 if I divide both sides by 3. So x is negative 3, that's my start. Excuse me, x is negative 2, that's my start. X is negative 2, but I got to figure out what y is. So now I plug this back in, that negative 2, back into one of these equations or both. So 2 times negative 2 plus 7 is negative 4 plus 7, which is 3. So y equals 3 when x equals negative 2. And so there's my solution, negative 2, 3, again, using the equal values method. So using algebra, where you set them equal to each other, solve for x, and then take that x, plug it back into the one of the equations, and I just chose to plug it into 2x plus 1 plus 7, plug the x back in, do my math, got my y, so I get the same answer. So it says, did your solution part B match your result in part A? Yes, it should. If not, check your work carefully and look for the mistakes in your algebraic process of your graph. So of course they match because it's two methods to get the same solution. Two methods to obtain the same solution. Okay, there we go.